Okay, welcome to Sine Rule. Again, this is it's trigonometry used on a non-right angle triangle. So we have to label our sides differently. We can't use adjacent, opposite, hypotenuse anymore because they are all labeled in relation to where the right angle is. And in this case, we don't have a right angle. Again, that is the point, is that it's a non-right angle triangle. So just to recap, if you're watching sine rule before cosine rule, we label the sides. We still need to label the sides, but we label them differently for a non-right angle triangle, and we label our angles first with A, B, and C using capital uppercase letters, and then we use that to find the corresponding side. So we have lowercase a is opposite angle A. So this is angle A, this is side A because it's opposite. This is angle B, and this is side B because it is the side opposite the angle. And then this is angle C, so this is side C because again they are opposite. So we talk about them being like side angle pairs, and that will come in useful when we are talking about how we use the sine rule to answer questions, how we find missing lengths, missing angles, and then moving on to where you might have potentially two different possible answers for a question, which is kind of a newer part to A level that you don't see so much in IGCSE. Okay, so this is our general form of sine rule, and it says that if we take side A and divide it by, so it's going to sound the same, side with a D, A, and divide it by sine of the angle A, then we do that for each side angle pair, then we would get the same answer. They are all within the same ratio. So for each side angle pair, if we divide the side by sin of the angle, then we get the same answer as if we did a different side angle pair or the other side angle pair. So all three of those ratios give you the same answer. We can flip that on its head. This is more useful if we are trying to find a side. This is more useful if we are trying to find an angle. Because it is so easy to just flip the fractions over, I would absolutely always use this one if we are talking about a side, trying to find a missing side, and I would always use this one if I'm trying to find a missing angle. We know we can use sine rule if we have two side angle pairs with one piece of information missing. So either one full side angle pair and then another with a missing side, or a side angle pair and another with a missing angle. We need to be able to match up a side in an angle and another side in an angle. The third angle and the third side we're not so interested in, as long as we have two side angle pairs. I hope that makes sense. Let's have a look at it in action. So we have a triangle, we have two angles, we have two sides. If we check, they are side angle pairs. Oh, I didn't mean to do that. This x is opposite this 30, and this 8 is opposite the 40. So we have two side angle pairs. Yes, we have a missing piece of information, but that's the point. We're going to use it to work out what x is. And we are finding a length. So I'm going to use the first form of the equation. So I'm going to call this angle A, so this becomes side A, and this is angle B, so this becomes side C. And we are not going to use, B, not C. And we're not going to use C at all. We could leave it blank. We can label it if we want to, but we don't need it, so I'm just going to ignore it. And I'm only going to use two parts of the equation, because that's all I need to be able to find a missing side. So I have x over sin 30 is equal to 8 over sin 40. I need to do a little bit of rearranging to get x on its own. So x is equal to 8 times by sin 30, because I have multiplied that sin 30 over, divided by sin 40. And then I'm going to put that into my calculator and work out what x is, which is nice and easy. So I'm doing 8 times by sin 30, and I'm dividing that by sin 40, which gives me 6.22 to 3 significant figures. That is a length, so it's centimetres, and that has been rounded to 3 sig figs. And that's it. You know, nice and easy to find a length. That is literally all you need to do. Yeah, I don't think there's anything else to say. I'm just checking I've got the right answer. Yeah. Yeah, so let's have a look at how we can use it to find an angle. So again, we have 2 side angle pairs. If I call this angle A, then this would be side A, and if I call this angle B, then this would be side B. So we have 2 side angle pairs. We're going to use the formula kind of upside down now to find an angle. So I have sin x, because that's what I'm trying to find, divided by 3.8 is equal to sin 35 divided by 5.2. Again, I need to rearrange to get at least sin x on its own for now. So I have sin 35 times by 3.8 over 5.2. I'm going to type that straight into my calculator. There's a lot less like simplifying needed for sine rule than cosine rule, because the formula is a lot simpler to use. Divide by 5.2. And that gives me sin x is equal to 0.419, etc. Again, I'm not rounding that on my calculator. I am leaving it as it is. And then I'm going to do, to find x, I need to use inverse sine. So I'm doing sin minus 1 of that answer. Gives me 24.8, if I round it properly, degrees. And that is again to 3 significant figures. And that's it. Couldn't be more straightforward. Okay, the basic questions and the basic use of the sine rule is a lot easier than cosine rule. It is a lot more, it's just a much easier formula to use. A lot less rearranging if you're finding an angle. A lot less things to try and worry about. There's no negatives to get stressed about or anything like that. Much easier. Where it does get a bit more complicated is when we have something like this. So depending on what sides and angles you've been given, you might find yourself in a situation where you could have 2 different answers. Okay, so for given side lengths B and C, so C is this one that we've got here, B is the one where we're going to draw in to join these 2 lines up, and a given angle B, so you would know what this angle here is. I'm going to write that in like that. You could draw the triangle in 2 ways. Okay, so I have a length B. If I think about the length B as being the radius of a circle, so the center of that circle is here at A, and it's got a radius of B, that could potentially cross this line at the bottom, which would be my length A. It could cross it in 2 different places. So if I imagine like so here's my radius of the circle, it would go like this, and it would kind of cut in 2 places. So it's a terrible drawing. But basically that circle has a radius of B, so it could join here, or it could join over there, which obviously would give you 2 different angles. This angle here is obtuse. This angle here is acute. But both of these lengths are the same. I'm going to call it B1 and B2, but they are the same length. Whatever B is, those are the same, which gives you a isosceles triangle, okay, which is important because it helps us work out what the two angles are. So if this angle was, say, theta, then because this is an isosceles, this would also be theta, right? Because it's isosceles, it would be the same. Base angles and an isosceles triangle are the same. This angle, which is the one I'm interested on the outside here, that would actually be 180 minus theta, because this is a straight line, this is theta. So the relationship, I'm going to get rid of this because I'm not interested in it, but the relationship between those two angles is that one is, if whatever one is, the other one is 180 minus it, okay? So the sine rule sometimes produces two possible solutions for a missing angle. Again, thinking back to when we looked at the sine graph, it goes like this. So sine theta could be like, say, here. This would be 0 and this would be 180. And you can see that if we read off, there are two values of theta for that to work, because they would both give you the same value of sine theta. So there are two ways. Using the graph, you can see why it works and where it comes from, okay? If the graph's confused you, ignore me, but this is important. So there are always, or they're not always, but sometimes there are two possible solutions for a missing angle when you are using the sine rule. So we'll have a look at how we can use that and what a question would look like on the next page. So in triangle ABC, so we've got A and B already. C is going to be either here or here. AB is 4, AC is 3. AC is what I'm going to be drawing on, and angle ABC is 44. Okay, so it's important with the things that you've got. So this is, say, angle A would be here at the top once you've drawn it in. This is side A, this kind of line that we don't know the length of. This is side C, and we need to find angle C. This is angle B, and the line B is what we are going to draw in. So it's going to be either here or here. Regardless, it is 3 centimeters. Okay, whichever one we choose, it's going to be 3 centimeters, but we're going to have either this obtuse angle or this acute angle. So to do it, we are going to use sine rule in the same way. Okay, we are going to find a side angle pair and we are going to work out the missing angle. So to do that, we are using, this would be angles, so I say that's C1 and this would be C2. So I have sin, what am I doing? I'm trying to find my pen. I've got the pen open. Okay, I would have sin C over C is equal to sin B over B. This is this double line, this 3 meter line is my B. Put in what I know. Sin C is what I'm trying to work out, and we're dividing it by the length of the side C, which is 4. I need the C, don't I? Sin B is sin 44, and we're dividing it by the side B, which is the 3, which is the line that we're not sure exactly where it goes. Rearrange it, so we get sin C is equal to sin 44 times by 4 divided by 3, which is, and I put it in my calculator, sin 44 times by 4 divided by 3 is 0.926, and again, it goes on, it's a really long decimal. I'm going to leave it as it is to find what angle C is as accurately as possible, so I'm doing shift sin minus 1 of my answer is 67.85. So I've done sin minus 1 of this answer, and that gave me 67.923 significant figures. Okay, but the question asked me for 2 possible values, so I know I need to use this. okay? So to get the other value of C, so if this is C1, the other value of C would be 180 minus 67.9. That is equal to 180 minus 67.9, probably could have done that in my head, is 112.1. These are angles, so they're both in degrees. They're both the three significant figures. No, they're not. That's a lie. That's 112.1 is four significant figures. They're both to one decimal place. Yeah, so you're solving it in the same way. The only bit that's tricky is kind of working out from the question, what are your side angle pairs? Which angle was with which side and things. Again, the best way to do that, if you were just given this information, the best way to do that is to draw yourself a diagram. It's a diagram it's an ambiguous diagram because it has two possible solutions, but it's a diagram all the same and it will help. Yeah, so basic sine rule, lovely, nice and easy. Even this two possible values, you don't have to understand too much where it comes from and why it works. All you have to know, the clues in the question, work out two possible values, you use your sine rule as you normally would. Then when you get your answer, you also need to take it away from 180 to get your second answer. Yeah, there's always a hint in the question of what you need to do. It's like if you're solving a quadratic and it says give your answer to three significant figures, you're going to need to use the quadratic formula. Yeah, it's like that kind of thing. So I hope that helps. Yeah, thanks for listening to me and have a lovely day.